So for section 3.3, we are going to just focus on some word problems. What have we learned from sections 1.1 or 3.1 and 3.2? So what we want to look at is how can we take word problems and put them into a context of linear functions. So for instance, if I have a parking garage, okay? So a parking garage, okay, and it charges $5, okay? So I know beyond the shadow of a doubt, I'm going to have to pay $5, okay? And then I have to pay an additional 45 cents every half hour. Every half hour I have to pay 45 more cents. So I want to identify a cost function. So we're going to label this as C of X. So cost in terms of X is going to give us what answer? So what this means is when I start writing this in mathematical notation, okay, it's going to tell me what I have for an answer. It's going to tell me what my actual final answer is, okay? So, hang on one second. This is killing me. All right. I'm trying to move stuff out of the way, and it won't let me move it. Move. All right. So, I'm sorry, my screen. I was trying to move my computer screen around, which you can't see. So, I want to know what my linear cost function is, okay? So again, what is this going to tell us? It's going to tell me the cost when the variable I'm playing with is x's. What is the cost of parking this parking garage? So what do I know beyond the shadow of a doubt? I am going to have to pay $5. Even if I just drive in and drive straight back out, okay? If I'm in the parking garage for 5 seconds, I'm going to have to pay $5. Okay, so for every half hour beyond that, I'm going to have to pay 45 cents. So for the first half hour, that'll be a 1. So I'll end up paying $5.45. Okay. For the second half hour, which would be a full hour, okay, I'll have to pay 90 cents on top of the $5. Okay, so this is your linear cost function, and that's going to tell you, well, what happens if I, do 20 hours? Well, that's going to cost me a whole bunch more money. Okay, so 20 hours is going to be $14, okay, because 20 times 45, and then plus 5, okay? So that is your linear cost function. So what we're doing is we're trying to write things that we can use in real life, and then what does it look like in mathematical notation? So I am going to do... I have a fixed cost of $100. So this is just a random problem. Okay, my fixed cost is $100. Okay, fixed means that is immovable, kind of like there's a fixed cost of $5 for my parking garage. Okay, that is not going to change. So I got a fixed cost of $100. 20 items will cost me $500 to produce. Okay. So what I want to do is work backwards, and I want to find out what the original cost function was. So if you just take the context out, what you have found is 1 point on the graph. Okay, 1 point on the graph, because if you shove in a 20, it's going to pop out a 500. Okay, so a point on the graph. So what does that look like? What I can do is say y equals mx plus b. Okay, so b is always going to be your fixed cost. It is set in stone. So just like up here, my fixed cost was 5. So your b, this is also your y-intercept. That's where it hits the y-axis. Okay, so here, your fixed cost is going to be where it hits the y-axis. So it's your y-intercept. So what do I know right now? I know a point on this graph. I know that if I shove in a 20, okay, so there's your x and there's your y. now, all right, hang on, pause. Because you're like, but the y-intercept, okay. So the deal is that there's an infinite number of y values. There's only one y-intercept. There's only one place where it's going to slice through the y-axis. So you can have an infinite number of y-coordinates, but there's only one y-intercept. So this is the y-intercept. This is y-coordinates, okay? So if I shove in a 20 in for my x, I'm going to get an answer of 500. Well, what do I know about my fixed cost? I don't care what anything else is. That's going to be 100. Okay, so now how do I solve this? Because I want to find my linear cost function. So I'm going to subtract 100 from both sides. And that gives me 400 equals, and you're used to seeing that as 20m. Okay, so m times 20 is the same thing as 20 times m. Well, now how do I get m by itself? Divide both sides by 20. So I get 1m is equal to how many times does 2 go into 40? It goes in 20 times. So your slope is going to be 20. Well, what does that mean? On a graph, it means it's going to move for every one that you move to the right, it'll go up 20 units. What does that mean as far as our cost function goes? Okay, so my fixed cost is $100. Every item costs $20 to produce. Every item costs $20 to produce. So what is your linear cost function? I've got y equals $20. Oops, sorry. Holy cow. Y equals $20 for every item produced, plus the $100 I know I got to pay. Okay, plus the $100 I know I got to pay. So that's your linear cost function. Okay, so let's try a couple more. All right, I have, flip. All right, so what I have is marginal cost. Okay, so my marginal cost is the fancy way of saying your slope, okay? So outside of this context, it's just referring to slope. But inside this context, it's a cost per item, okay? It's your marginal cost. So what do I know? I am told that my marginal cost, so my marginal cost is going to be $50. Okay, that tells you the price per unit. Okay, the price per unit. I'm also told that 130 items is going to cost me $9,000 to produce. Okay, 130 items will cost me $9,000 to produce. So I need to know, how do I fix this thing? So again, everything in this section is going to go back to y equals mx plus b, because that's linear. So I'm given an x, and I'm given a y, and I'm also told my marginal cost, or I'm told the slope. Okay, so I know an x and a y and an m. What do I not know? I don't know my fixed cost. So my fixed cost, or my y-intercept, is what I'm going to be looking for. Okay, so just start plugging this stuff in. So do I know a y value? I do. He's 9,000. Do I know an m? I do. It's 50. So that's my cost per unit. I also know an x value of 130. Okay, so it's going to cost me $50 per unit. I produced 130 units for a cost of $9,000. That means I don't know how much my fixed cost is. I don't know what my y-intercept is. So what is 5 times 130? 5 times 130 is going to give you 650. Okay? 50 times 130, okay, is going to give you 6,500. Okay? So this is 6,500 plus b. Well, now how do I get b by itself? I'm going to subtract 6,500 from both sides, and that's going to give me 2,500 is what b is. Okay? 2,500 is what b is. So what does that mean? That means that my final cost function is y equals, or you could say c of x equals, either way, Okay, what is your cost per unit? $50 per unit. And my fixed cost is $2,500. So either way, 50x plus 2,500. Now, how do you check your work? Okay, I know that this was 130. Okay, so 50 times 130 is 6,500. Plus my fixed cost of 2,500 gives me 9,000. Okay, so it works out. It makes sense. Okay, so let's try a few more. We've got, so I am given a cost function. So given a cost function, we've had to figure out what the cost function was. Okay, well now it's given to me. Given a cost function, find the average cost per item when the required number of items is produced. Okay, what is the average cost per item when the required number of items is produced? So first of all, I am given a cost function, and it is 7.7x, okay, plus 9,500. Okay, so what does that mean in terms of a cost function? My fixed cost is 9,500. That's what I start with, okay? It's going to cost me $7.70 per unit. $7.70 per unit. So I would like to know three different numbers. If I produce 200 items, if I produce 2,000 items, and if I produce 5,000 items, what is my average cost per item? So if this is my cost function, okay, I'm kind of giving you some more information. I want to know the average cost. I want to know the average cost, okay? So if I want to know the average cost, what I can do is divide everything by x. Now, what on God's green earth does that mean? How do I take an average? Okay, so let's say I have 3 donuts. That's a lot of donuts. Okay, and I have 6 donuts, and I have 7 donuts. What is the average, let's just say Monday, Tuesday, Wednesday. What is the average number of donuts that I had? Okay, so 3 plus 6 is 9, plus 7 is 16. Okay, that's the total number of donuts I had. Well, then how do I find the average number of donuts? I divide by the number of donuts, or the number of occurrences. Okay, so divide by 3, and I'm going to get 5 1/3 donuts was the average number of donuts I ate per day. Okay, so that is what I'm going to work with to find. So when we say you're going to divide by your average, okay, that's what we're doing. So if I've got 200 units produced, I'm going to end up dividing my answer by 200. Okay, I'm going to end up dividing my answer by 200. So I'm going to modify my formula a little bit. Since this is the cost function, I'm going to find the average cost function, and I'm going to call that bar x, literally bar x. Okay, bar x. And all that means is divide everything by x. You're going to average it out. That's all you're doing. Okay, so if I want to find the average cost function, so I'm going to use C bar x equals 7.7 times 200 plus 9,500. So all I did was shove that 200 in for x, but then the new part is I need to divide my answer by 200. Okay, so on my calculator, so this part is familiar, okay? The new part is divide it, okay? The new part is divide it. So if I have, I'm doing this on my cell phone because my daughter stole my calculator. All right, so the new part is 7.7 times 200 is plus 9,500 is. So my cost function was 11,040. But I want to know the average cost. So divide it by 200 and I get $55.20. Okay, so that's $55.20. In other words, if I produce 200 items, it essentially costs me $55.20 per item to produce. All right, so let's do 2,000. Okay, so C bar X of 2,000 means I'm going to change this to a 2,000, and I'm going to change this to a 2,000. Okay, so 7.7 times 2,000 is, plus 9,500 is, and then divide it by 2,000. And I get $12.45. Okay, so what happened? The more things I produced, the cheaper it was for me to do it. The more things I produced, the cheaper it was for me to do it. So think about that. If you get a handmade item, okay, somebody makes you a piece of pottery by hand, that costs a whole lot of money. But if you buy it from a factory, it's really cheap. Okay, if you buy it from a factory, it's really cheap. So that's why. The more that you're producing, the less it costs. So now do the last one. So 7.7 times 5,000. And then I have plus 9,500. Oops, not 95,000. No. Divided by 5,000 is going to give me 9.6. Okay, so I put a 5,000 here and a 5,000 here, and now it's only $9.60 per item to produce. $9.60 per item. So we'll pick up again on a next video.